Okay, so we did an activity with fences, which I'll get to in a second. But again, what we're practicing is first we're going to notice a pattern, then we're going to describe the pattern, then we're going to generalize the pattern. So before we get started, we need to make sure we have two definitions. The first one is perimeter, and perimeter is really what you consider the distance around the outside of a shape. So one way that you could think about this is if you took a little stick figure person, which seems to be my favorite thing these days, and you had this person walk all the way and then here and then here and then here, how far did that person walk? So in this case, let's say this side right here is like 24 meters, which means the bottom side is also 24 meters. And then maybe this side is 12 meters and this side is 12 meters. Then what you would get is 24 plus 12 plus 24 plus 12. Here we'd get 36. This would also be 36. We add those together and you would get a perimeter of 72 meters. That's how far this little green dude would have to, if they start here and they walk here, 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 and here. That's what perimeter is. The other word that we need is area. And area refers to the amount of space on the inside of a shape, and it is measured in square units. So if I was going to fill in the area here, the whole area would be everything that I just colored in purple, including that tiny little bit in the two. And really the way that we would measure this is in square units. And one way you could see those square units is if you imagined like a grid of 12 going this way and 24 going this way, and then it's how many little squares you have. Kind of like that, where I have 12 down here and I have 24 across here. And to figure out how many of these little squares you have in total, you would just take 12 and multiply it by 24. 12 times 24, in this case, would get us 288 meters squared. And again, this is kind of why we call it squared with a 2, is that they make little squares. So here there should be 288 little tiny squares. Okay, so perimeter and area, we need those. So again, our job is going to be notice, describe, and generalize this pattern. Here's what we're going to have. We have several rectangles here, and let's notice some things about them first. This one has 5 meters here. Now, if it's a rectangle, this side down here is also going to be 5 meters. If this one right here is 20, then this one is also going to be 20 meters. And the same thing would be true here, where if this is 12, here I get 12, 13, 15, and 10. Okay, since we've been talking about perimeter, let's look at the perimeter of each of these shapes. And I notice here I have 5 plus 20 would get me 25. And since this side is 5 and 20, I'm pretty sure 5 and 20 here would get me another 25. So I would have 25 times 2, or 50 meters in perimeter, right? Over here, we'd have 12 plus 13. That gets us 25. Hey, here would be another 25. And then I would get a total of 50. And then, hey, check it out. Here I would have 15 and 10 gets me 25, plus another 15 and another 10 gets me a total of 50 meters. So all of these rectangles have 50-meter perimeters. But what about the areas? And I'm going to do all of these in green so that we can kind of keep it. Sorry, I went a little crazy. Area, the way that we would get that, it was just multiply length times width. So in this case, I would have 5 times 20 is 100 meters squared. Here we would have 12 times 13, which would get me 144, plus another 12 would get me 156 meters squared. And here we would have 15 times 10, which would get us 150 meters squared. So in this case, my 100, my 156, and my 150 are not the same. Okay, this leads us to notice, shockingly, Ms. Perkins was a little messy here. So let's see if we can organize this a little bit better. One of the best ways to organize is to make a table. So in this case, we're going to make a table, and we're going to have a couple different things as part of the table. We're going to have length, width, perimeter, and area. And just to be a little bit more organized, we're going to call this rectangle A, this one B, and this one C. So in rectangle A, so I'm just abbreviating rectangle A, the length, and it doesn't really matter which way you want to organize this. You could have length go up and down, or you could have width go up and down. I'm just going to go length and width here. Hopefully you're okay with that. So the length for rectangle A is 5 meters. The width in this case is 20 meters. The perimeter, which again is the distance all the way around, well, we figured that out, that the perimeter for all of these was 50 meters. And the area is this 5 times 20 is 100 meters squared. That's rectangle A. Rectangle B, we had 12 and 13, 50 meter perimeter, and 156. Maybe pause for a second and see if you guys can fill in rectangle C by yourself. Pause, pause, pause. Cool. Okay, let's now that we've gotten a little bit more organized, I want us to notice some things. One thing that I am noticing is that these always add to 25, right? 5 and 20 is 25. 12 plus 13 is 25. 15 and 10 is 25, which makes sense because half of the rectangle is going to be half of the perimeter. 50 divided by 2 is 25. So all of these have same perimeter, and they all happen to have different areas. So one of the questions I have is, what are all of the different rectangles we could have where the perimeter is the same, but the length and width change so you get different shapes? And then maybe what's the biggest area that I can get for my rectangles? So here's what I'm going to do. I'm going to start describing. So we said notice. Now we're going to describe by saying, okay, what if I just kind of made a pattern with the lengths? What could I deduce over here? We already know this one, right? This was from before. We knew that if it was 5 in the length, the width would be 20, the perimeter would still be 50, and the area would be, 100 meters squared. Meters, meters, meters. I'm just going to add that label up here. Okay, so if I had, again, we want a perimeter of 50 meters for everyone. So those all have a perimeter of 50. Well, what would the widths end up being here? If I was going to sketch out these rectangles, we know that the length plus the width has to equal 25. So let's say I made these two purple sides 4 meters long. I know that this plus this has to equal 25. What do I need to add to 4 to get 25? Well, that would get me 21. So I'm going to add that this would be 21 meters. Then over here, to figure out the area, I would simply do 4 times 21. And I'm going to just do that off to the side. And that would get me 84 meters squared. Pause for a second and see how many of these you can fill in. I trust that you can do this. I know you can. And again, be looking for patterns, because I set this out kind of nicely where it should work out pretty well for you. Hopefully you took a second there. What you'd end up with are these numbers: 0 and 25 pair, 1 and 24, 2 and 23, 3 and 22, and so on down. And then these numbers, like, for example, this one right here, that 136 is 8 times 17 gets me 136. So what I'm noticing is as the length is getting bigger, my area is getting bigger. Is that going to continue forever? Or could I start generalizing, which is kind of what we talked about earlier? And what if I had just some random letter like X here? What do I know about what the width would be if I just said this was some random letter X? Well, I know that X plus whatever goes here has to equal 25. So one way you could write this is 25 minus X, right? 25 minus 15 is 10. 25 minus 20 is 5. You could pick any of these and that should work out for all of them. The perimeter would still be 50 for all of them, and then the area here would just be X times 25 minus X. And this is where things work out really nicely, because now I could test and see. So in fact, let's check this with, like, let's use this row right here. Let's say X was equal to 6. Then 25 minus 6, what's that? Oh, hey, that's 19. Check it out, that works out. If I had a width of 6 and a length of 19, it would go kind of like this, where I'd have 6 and 19 and 6 and 19. And hey, if you add all of those together, you get 50. And then if you were going to multiply over here, if you make X 6 times 25 minus 6, this part here ends up being 19, and you get 6 times 19, and that should work out to 114 meters squared. So we just checked that this worked with one of the ones we already had, but what if X was 11? Then that would be we could use this to help us get the next one. So the idea of what we're trying to do here is we're trying to eventually get the pattern here where we could then start graphing it. And that I am going to leave to you all. What does it look like when you graph this? Check that out. That should help you with your project that's coming soon. Let me know what questions you have.